Hi, so this is the final video for the series on the physical and chemical properties of seawater. So we are now to properties of seawater, and hopefully you guys have watched all the other videos already. You should have watched them in order. So if you haven't watched all of the videos yet, please go back and watch them before I move on to properties of seawater. Okay, so seawater now. So water is a solution, and this is because there's stuff dissolved in the water. So seawater is a solution of water molecules and dissolved gases and solids. The water molecules are called the solvent, and the dissolved substances are called the solutes. Okay, so seawater is considered a solution because it has pure water molecules and other things dissolved into it. Okay, and the reason why, again, water can dissolve so much stuff is because of its polarity, because it is positively charged on one end, the hydrogen side, and is negatively charged on the other end, the oxygen side. Therefore, it can bond to anything else that is polar or anything else that is charged. So seawater is made up of water and dissolved particles, so salts, metals, and gases. And we use a term to describe how many solid particles are dissolved in seawater. The term is salinity. So salinity is the amount of solid particles dissolved in seawater, and it's measured as the amount of salt dissolved in 1,000 grams of seawater. So we write that as this little symbol, which means parts per thousand. So if I were to cover up one of those zeros there, you can see the remaining symbol is percent, right? That is percent. So that is per 100, or parts per 100. This, with two little circles there, that means parts per 1,000. Okay, so how many grams of salt or other solid particles are dissolved in 1,000 grams of seawater? That is salinity. So up here on the upper left, we have a sample of seawater. We have a 1,000 gram sample of seawater. Of that 1,000 grams of seawater, 965.6 grams is pure water. Okay, so seawater is 96.5% pure water. And the remaining 3.5% are other components that are dissolved into the water. So that's out of 1,000 grams of seawater, 34.4 grams are dissolved substances. So on average, salinity of seawater is about 35 parts per thousand, or 3.5% salt and other constituents. So what is that salt and other constituents? So this is showing you just that little piece right there. So breaking that down for you. You have, of that 34.4 grams of dissolved solids, we have 18.980 grams of chloride, we have 10.556 grams of sodium, then we have sulfate, magnesium, bicarbonate, calcium, potassium, and other things which even include metals such as gold. Okay, so salinity can be expressed as a percentage. So salinity of 4% means that in 100 grams of seawater, 4 grams dissolved solids and 96 grams are pure water. So remember, 4%, that's per 100. So if you have 100 grams of seawater and 4% of that is dissolved salts, then that means 4 grams of dissolved salts. But like I said, it's more commonly expressed as parts per thousand, which can be written with this symbol here, remember, parts per thousand, or PPT. So that means that if you have a salinity of 4 parts per thousand in 1,000 grams of seawater, that would be 4 grams of dissolved salts and 996 grams of pure water. Okay, so which one has more salt in it? This example up here, 4 grams of salts in 100 grams of seawater, or 4 grams of salts in 1,000 grams of seawater. You should have said the first one has a higher salinity. Okay, so on average, the ocean salinity is about 35 parts per 1,000, or 3.5%. Okay, so let's try a salinity calculation. If you take a 1,000 gram sample of water and determine that it contains 20 grams of salt, what would the salinity be in parts per 1,000? So 20 grams in 1,000 grams. That should be 20 parts per 1,000, okay? Then what would it be in percent? So 20 grams in 1,000 grams in percent form, so we could change that to in 100 grams and get rid of a zero, right? Then you get rid of the zero from the 20 grams too, so that becomes 2 grams per 100 grams, which means 2%. Okay, so how does salt water differ from pure water? Well, one, the pH of fresh water is 7, or neutral, while the pH of seawater is 8.1, or basic. So seawater is actually slightly basic rather than being neutral. We'll talk a little bit more about pH in the next video that you watch on marine chemistry. Additionally, the density of seawater is greater than that of pure water. If you add salt to water, it makes it more dense. So the density of pure water is 1.000 grams per cubic centimeter, while the density of seawater is 1.028 grams per cubic centimeter. Additionally, the freezing point is lower for salt water, and that's why in places in the world, especially in the United States, that get very cold in the winter time and the roads freeze, they put salt on the roads, because that means that if there's salt on the roads, and that salt mixes with the water, and that makes salt water, and that means that it needs to get to a lower temperature than just 0 degrees Celsius in order for it to freeze. And therefore the road doesn't freeze, or it's less likely to freeze if you put salt on it, and that means it's less slippery and there's less accidents. Salt water also has a lower specific heat and latent heat capacity than fresh water, which means that it can heat up more quickly than fresh water does, and it also means that it could boil more quickly than fresh water does as well. So it takes about 0.96 calories to raise 1 gram of liquid water 1 degree Celsius, and for pure water it would be 1 calorie to raise 1 gram, so it's just slightly lower. Okay, so this image is showing you the connection of water with our ocean, with our land, and with our atmosphere. So Earth's water supply is found in oceans, it's found in lakes, it's found in glaciers, but the majority of it is found in the oceans. 97.5% of our water supply is locked in our oceans. 1.8% is in glaciers and ice caps, and the remaining 0.7% is in groundwater and soil, found as water vapor, and also in lakes and streams. So this is showing you how water cycles between the ocean, between the atmosphere, and from the land, and back to the ocean again. So we have this big, 70% of Earth is covered by ocean. So when that ocean heats up, the water evaporates, or some of the water evaporates, and that evaporation goes into the atmosphere, right? So now we have water vapor in the atmosphere. That water vapor rises up into colder area of our atmosphere, and therefore it can't stay as a water vapor, so it's released back as rain. So that could be, that rain could fall back on the ocean, or the rain could fall back on land. If the rain falls back on land, depending on how cold it is, it could add to glaciers on land, or it could just be rain, and that just flows into lakes and can seep into groundwater, and eventually the water will run by way of rivers back to the ocean again. So in this way, water cycles between the ocean, the atmosphere, and the land, and back to the ocean again. Okay, so how would this water cycle, this movement of water through our planet, how would this affect the seawater's salinity at a given location? So if you have rain, precipitation, if you have runoff, which is fresh water from land running into the ocean, if you have melting of icebergs, which means you have ice floating in the water, or you have ice on land melting and going into the ocean. That all of those processes, because that's adding fresh water, that decreases the salinity in that area. The opposite occurs with evaporation, because when water evaporates, the salt is actually left behind. So that's going to increase the salinity, right? Because you're removing fresh water from the ocean and leaving behind salt, so it becomes more concentrated in that area. Additionally, if you have ice forming on the sea, that ice again forms and leaves the salt behind, just like with evaporation. And so you're taking fresh water out of the ocean and leaving salt behind, which again makes it more concentrated. Okay, so the processes of adding fresh water to the ocean will make it less saline. The process of taking fresh water out of the ocean will make it more saline. And we're going to talk about this after our first exam, where we discuss atmospheric circulation and ocean circulation. Okay, if you have any questions, please post them. And this image is showing you what happens when you have very salty water. When the salt concentration is high, that means that the water becomes more dense, and that's why this woman is able to easily float on the water. Okay, I hope you have a good day or night.